Welcome to Fresh Thinking podcast. Here we explore all the new ideas for more sustainable mining, and I'm your host today, Gregory Zhang, senior consultant with Snowden Optiro, with 14 years of experiences across academic, exploration, and resource estimation. Today, we're going to talk about grade control drilling and modeling. So that topic might seem technical, but actually sits at the heart of every successful mine. So to guide us through, I'm joined by Ian Glacken, so executive consultant with Snowden Optiro for many, many years. So glad to have you here. Yeah.
Thanks for inviting me, Greg, if I can call you Greg. Yes, I'm very passionate about grade control. I've been involved with grade control and reconciliation for many years, so it's always good to have a talk about that, particularly as it directly influences the profitability of a mine.
Awesome. So let's start with the basics. For listeners who are not mine geologists, so why do we need grade control at all?
Well, some would say we don't, and that's a controversial point, but most mines these days have at least two phases of drilling or sampling. So you would have the exploration phase, where you find the ore body. Then you would have the resource development phase, when you get to the stage where you know that you've got something to mine, and then you would start mining it. Mm-hmm. And then you would have a third phase, or a final phase, if you like, which would be grade control drilling. And grade control drilling, I would like to think of it as the last stage before we actually mine the thing. Now, we talk about drilling, but it's not just drilling, it's also sampling as well, and potentially mapping. So the purpose of this is to provide the best snapshot of two purposes really: the best snapshot of the material that we're going to mine, and the second purpose is really to tell us where we're going to mine. So that's the main purpose, is to direct the mining with the detailed and final phase of drilling and sampling.
Okay, so good. So it's essentially about reducing the risk and maximizing the value. So basically the last step where we can give the best estimation before really all the mining equipment hits the ground. So I'm sure the sampling quality and quantity matters here, as you said. So grade control modeling is just like any other type of modeling, that sampling must be representative. But also the sampling here for grade control stage needs to be timely as well. So can you expand on the sampling methods and how do we ensure the quality?
Sure. So grade control drilling and sampling is important, as you say, and it's important to get the quality right. It's also important to understand that in some ways it's just-in-time sampling. Now, what does that mean? That means that quite often when you're doing the grade control drilling or sampling, you don't have as much time as you might have, say, for the exploration drilling or the resource development drilling. So there is a time pressure on you, but at the same time, it's important to get that quality. So essentially the methods for in an open pit mine for grade control sampling would be RC drilling, sometimes diamond drilling, but not very often, and blast hole sampling. Now, blast hole sampling is not as good as RC drilling. For those of you that don't know the difference between RC drilling and blast hole drilling is that with blast hole drilling, the particles come up the side of the hole and they can contaminate, whereas with RC drilling, the particles come up the center of the rods and there's less contamination. So RC drilling is generally accepted as a much better drilling sampling technique. However, having said that, because of these time pressures, and because of the situation where we only need to drill the holes once with blast holes, we do still see some blast hole sampling. Now, in some commodities like iron ore, bauxite, and some base metals, that's fine, probably fine. In other commodities like silver or gold or precious metals, it's probably not fine. So that's essentially your choice. Look, most of the time these days, and it's very different to when I started many years ago, blast hole drilling was just about the only grade control sampling technique. These days, I'd say it's flipped around so that RC drilling is the majority of grade control sampling techniques. But it's really all about assuring yourself of the quality of the sampling.
Excellent. Thanks, Ian. And you talked about the open pit, but how about underground? How about the phase samples?
Underground, that's a good one. So we do have, in the case of underground mines, we do tend to see more diamond drilling as grade control because it's quite often you have a little bit more time underground between the resource development phase and the mining phase to do some grade control drilling. So we do see diamond drilling. We do see face sampling, which is where we actually sample the development phases. And this is probably not quite as poor as blast hole sampling, but it is something that needs to be looked at. What we do see in a few mines, not many, is underground RC drilling. And there are 2 or 3 or 4 mines in Australia and some worldwide where underground RC drilling is being done for grade control. So we have the same techniques. We do see more diamond drilling for grade control purposes, and we do see face sampling for grade control purposes. Face sampling obviously is restricted to the development drives, and we don't necessarily see all of the ore body in our development, whereas diamond drilling can define the ore body in 3D. So our key issue there is to make sure that our face sampling or chip sampling is high quality.
Okay, so what's the common issues with face sampling?
Well, the common issues are is getting a large enough sample. It's getting a representative sample. So if we treat a face sample as a drill hole that goes across the face, horizontal or vertically or whatever, we need to make sure within a certain interval, a 1 meter interval, that every particle or every bit of rock in that interval has an equal chance of being sampled. Now, if you're sampling something that's quite soft, like sulfides, in a hard rock matrix, you might overestimate or underestimate the ore portion. So one of the issues with face sampling is getting a large enough sample, and it's getting a sample that's representative. So they're really the key issues with face sampling.
So whether it's open pit or underground, always RC or diamond, if possible, I highly recommend it, rather than the blast holes or face samples.
That's right. You're not going to see too many diamond drill holes for grade control in an open pit, simply because of the time taken to set up a diamond drill rig, the logistics of a diamond rig, whereas you just don't have that much time in an open pit situation. Whereas with an RC rig, you can drill holes relatively quickly, you can move between holes relatively quickly, and of course with a blast hole, you're drilling the holes anyway for blasting. So whereas, as I said to you, in underground, you've generally got more time, and the diamond drilling can stand off from the ore body. So it's possible you're not actually interrupting, in some cases, the development process. So that's why we tend to see different drilling, whether it's open pit or underground, for grade control.
Awesome, thanks. And that precision sounds very crucial. So does it tie back to the broader geological picture?
Yeah, for sure. It's a function of the mineralization. I talked about RC underground drilling earlier on, and one of the mines where it's practiced is Sunrise Dam, which is Anglo Gold Ashanti. Okay. And the reason they went to, or one of the reasons they went to RC underground drilling, was that the ore body was so heterogeneous, so difficult to sample, that they decided that the best way to sample it, which is the right way as it turned out, was to drill lots of holes. So in that case, the geology was very high nugget and very uncertain. Now, if you have an ore body that's like a single shear zone, you've got to intersect that shear zone. Your key issues there are getting the recovery. So the nature of the ore body, the geology, dictates the type of drilling and the amount of drilling that you have.
Cool. Awesome. In other words, no two deposits are exactly the same, so you need to judge by your best practice. So that leads me to the next topic. In Australia, the JORC Code governs how we report resources and reserves. So does the JORC Code require grade control?
Does the JORC Code talk about grade control drilling? It talks about drilling, but not specifically grade control drilling. If we're talking about a grade control model, the thing about a grade control model is it's something that comes in between the resource model, the reserve model, and production. The JORC Code, Joint Ore Reserves Committee Code, really talks about what we're actually reporting to the market. The vast majority of companies don't report their grade control models to the market because they're internal models for local control. So from that point of view, from that point of view, the grade control drilling isn't defined by the JORC. But what does happen though is that companies will do grade control drilling, say in an underground mine, there'll be underground diamond drilling that will be used for the grade control model, and then at the end of the year, it might be built into the resource and reserve models. So the drilling is in part of the bigger picture, but specifically for grade control purposes, the JORC Code isn't interested or concerned about grade control modeling, but the drilling needs to be of high quality.
Cool. And I think under that reserve reporting section, it does ask the competent person to describe something about the grade control modeling, for example, some assumptions, although without huge amount of the details, but there is such a request.
Only insofar as it relates to the reserve model, because the JORC talks about the reserve, and in many minds what happens at the grade control stage does impact the reserve. But if you're talking about a grade control model for predicting production, that really isn't part of the JORC code at the moment.
Great. So grade control is not a regulatory checkbox, but a technical necessity for most operations. So now another term that pops up is ground truth. So on the mine side, is ground control model usually deemed as a ground truth?
Is the grade control model deemed as the ground truth? Well, in some cases, yes. For one reason is that it's the final stage of sampling. We don't have any additional sampling. We might have some mapping or some blast hole cone sampling, for instance. So we don't have any more sampling. So from that point of view, it's as close to the truth as we're going to get. But the thing we need to remember, of course, is that we talk about the ground truth, but what we're actually going to take to the plant is the material that's been blasted. So it's going to change. It's going to change in shape and size and location. So while the grade control drilling in situ represents the ground truth, we do have that extra stage of production. So I would tend not to use the word ground truth. I would tend to use the phrase, it's the final phase of sampling for the ore body.
Awesome. So the message is treat the grade control data as your best estimate, but still remain skeptical because sampling and modeling errors still exist.
That's right.
Plus the blast movement.
That's right. Yeah. So we have movement, we have sampling errors. You know, we talked about sampling quite a lot on this podcast, and we have modeling errors, and we also talked about modeling errors quite a lot. So grade control models are more accurate simply because there's a lot more data. In some cases, we have 10 times as much data as the resource model. So from that point of view, it's the most accurate, but it certainly isn't the truth.
That's a great takeaway, and thanks, Ian, for sharing your expertise. Thank you for listening to Fresh Thinking. If you enjoyed this episode, please subscribe and share it with your colleagues. And we have our podcasts on all the main platforms. Thanks.